Hi everybody, so today we're going to talk about functional groups. Before we do that though, I just want to introduce you to something called isomers. Isomers are similar in the sense that they will have the same number of atoms, they will have the same molecular formulas, the same percent composition and empirical formula, but what makes an isomer unique is the fact that it has different structural formulas. And I've been alluding to this in class and in some of the videos about what an isomer is. And to give you an example of an isomer, if I were to have something that had 4 carbons arranged like this is butane. It has a formula C4H10. It has an empirical of C2H5, and you could go through and figure out the percent composition of carbon and hydrogen in there. Now, what if I were to try and make an isomer of this, something that had a different structure and therefore different properties? Well, what I could do is, and a common tactic, if they say make an isomer or something, you could take one of the N carbons and sort of put it in the middle, make the longest chain shorter, and so now if I go through and I count up the carbons here, I have C4H10. I can reduce that to C2H5. So the molecular formula, the number of atoms, the empirical formula, and if you calculate the percent composition will all be the same. But now this is a different compound. It has a different structure. Its name is methyl propane. So now because of its different structure, it will have different properties. And we're going to see this theme again and again. When we do the functional groups table R in a second, you'll see like, oh yeah, he's talking about what he says is isomer pairs. And those are substances that have different structures and therefore different properties. Alright, so let's talk a little bit about table R. So these compounds are sort of an add-on to what we've studied in hydrocarbons. They have more than just the carbon and hydrogen atoms that we saw in table Q. Now, table R is actually a really good reference table. It's pretty remarkable the amount of information that they give you if you know where to look for it. First of all, they tell you the type of compound. They tell you the functional group. That's the atoms that make the molecule, what class they are. So an OH would be an alcohol. A C double bond O, OH would be an acid. And so you'll see this. I'll show you the table in a couple of seconds. So that is also shown in the table, and also a named example. And what I love about the named examples is that some of them have numbers, and those numbers are not there on accident. They are actually telling you the number of carbon atoms when you need to start numbering. And we'll get into that, I'll show you. But think about that. It tells you when to start numbering. The most difficult part of naming compounds is when to number, and this table is telling you this is when you start numbering, and you're going to see that. And any isomers. So it'll show you isomer pairs, and I'll point those out to you. They don't mark them on the table, but they are organized based on isomer pair. Alright, so here it is, table R. So table R, it shows you, again, the class of the compound. Halide, alcohol, ether, some people say ether, but it's ether, aldehyde, ketone, organic acid, ester, amine, and amide. So these are all of the classes of the compound. They also tell you the functional group. So if it's a halide, it's going to contain a halogen. Alcohol will contain an OH, ether, an O in the middle of the chain, aldehyde, double bond O at the end of a chain, ketone, double bond O in the middle, organic acid, double bond O, OH at the end, ester, double bond O and O in the middle, amine, a nitrogen, and amide, C double bond O and a nitrogen. Those are all the functional groups. Now generally I don't really look that much at the general formula because I have it in the functional group. Just so that you know though, R represents one or more carbons. It could in some cases represent a hydrogen as well, although generally it is a group of carbons. Now, the example that they give you. So for the example, they give you a named example for Halides, they're named with the prefix in front. Chloro for chlorine, fluoro for fluorine, bromo for bromine, iodo for iodine. The alcohol, the ending changes. It becomes anol. And notice they have a number here for prop. That tells us that we generally do not number alcohols until we get to prop. We also see that with halides. We do not number halides until we get to 3 carbons prop. For ethers, we have one R group, we have the other R group, and then we have the word ether that comes after it. Aldehydes end in anal. Ketones end in anone. Again, look, there's a number, but they're telling us don't number until we get to pent. Pent is 5 carbons. Ketones, you only start numbering when you get to pent. For organic acids, the ending will be anoic acid. For esters, you'll have 2 names, a YL ending and an anoate ending. Amines will end in amine, and amides will end in amide. You don't need to memorize these, but you need to know how to take the examples and use them. So let's go through and do some naming examples here so that you can see what this looks like. So my first example here, if I want to name these, I try and identify what the functional group is. I look here and I see that it's C double bond OOH. I include both of the oxygens. And I go and I try and figure out what compound is that. Here it is, organic acid, C double bond OOH. Sometimes this will be written as COOH, condensed like that. So now I know this is an organic acid, and I know my ending is going to be anoic acid. Now I just need to put on the right number of carbons. I go back to table P, I look, I see there's 2 carbons, it's going to be F, anoic acid. Let's try naming the next one. The next one has, I look at the functional group, it has an O in the middle of the chain. I go back and I look on table R. Ah, here it is. Ethers has the O in the middle of the chain. So when I name the ether, table R names one group, so that'll be propyl. I try and do it alphabetically, this group, 2 carbons, ethyl, and then I put on the word ether. Let's compare that to what we have in table R here. They have methyl ethyl, but they have the word ether. Our number is going to be different. We have ethyl propyl because we have a carbon group of 3 and a carbon group of 2. Let's try the next one. So here we have an OH attached to 3 carbons. Well, let's see. OH is an alcohol. Alcohols end with anol. 3 carbons would be prop. Now let me check table R here really quickly. I go ahead, I check table R, and I see, wait a second, they're numbering this alcohol when it's prop. That means I need to number this alcohol with prop. It's on the first carbon, the OH. This would be 1-propanol. Now look, I could go through each of these examples, but try them on your own. Here's some more practice for you for trying some of these. Give them a try. Let's see how you do with it. Now, here's going the other way. In this case, they want us to name the carbon compound. So we have our pentanone. So now I go and I check out table R. I'm looking for anone. I see here anone is a ketone. The functional group for the ketone is what I'm going to start with. I'm going to start with the C double bonded to the O. And it's going to have 5 carbons. So we're going to have 5 carbons. Now, I could sort of work preemptively here. I see that it's 3 pentanone. So I want this on the 3rd carbon. So I'm going to make this 1, 2, 3, 4, 5 pent. 3 pentanone. I fill in the rest. Ethyl butanoate. Let's see if we can find that one. here we go, YL and a noate. Now this one is an ester, so I draw the functional group for the ester. The functional group for the ester looks like this. Now I need to make a decision. One of them ends with YL and one ends with a noate. And here's how I make this decision. The one that has the OAte part is the chain that's going to be part of the double bonded O. The name that has the O in it and no weight will be part of the chain that has the double bonded O. Now bute is 4, so I have 1 carbon, 2, 3, 4, butanoate. Ethyl is 2, that's going to be this chain here. So notice, the butanoate got this chain, the ethyl got this chain. Whenever you try and write one of these that has a, like they give you the structure they want, the name, look for the part that has the double bonded O. That's the name that gets the anoate. Look for the part that doesn't, that's the YL. That's the part that will not get the O. Now I fill in the blanks, 1, 2, 3, 4, 5, 6, 7. This O, C in the middle here is already taken care of. That O doesn't get any H's. These C's get their H's to fill their octet. So try this one over here. Try 2,3-dichloro-2-fluorobutane. Try that one on your own. Now look, here are some common uses for each of these types. I'm going to go briefly through them. Halides, those are used a lot in refrigerants. And they actually had a really bad effect on the ozone layer. They were depleting the ozone layer. And this was showing, this map here shows that purple part over Antarctica. That was the size of the hole of the ozone layer. These compounds would react with the ozone and destroy it. Alcohols, these have some common uses. Wood grain alcohol, this is something that you could ferment wood with. This, unfortunately, if you try and drink it, it's methanol, it causes blindness. Ethanol is drinking alcohol. It's used for fermentation, produced by fermentation, which we'll get into next time. But also the thing with ethanol is that it's also used now as a fuel additive to regular gasoline. It's produced from corn and soybeans. Rubbing alcohol is actually propanol. Propanol has, or isopropanol, or 2-propanol. This is the stuff used as an antiseptic. This is ethylene glycol, and this is the condensed skeletal structure. It actually looks like this. It's a glycol. It has 2 OHs. And so this is used as antifreeze. We'll come back, and in the next video, I'll talk about alcohols, a closer look. We'll talk about different types of alcohols. I just want to go through a few other of the compounds. Ethers, these were used as anesthetics. Early on when anesthesia was first being experimented with, and this was called the open drop method. This was prior to when they actually had more controlled methods. I'll go past that gangrenous arm. Aldehydes, the most common one is formaldehyde. This is used in embalming, preserving dead organisms. Ketones. They're really good solvents. They're also a key ingredient in plastics, and the most common one that you probably know about is propanone, which is acetone. That's commonly known as nail polish remover. Esters, I'll make an ester for you as a demonstration, but esters are made from an alcohol and an acid. We'll go over that reaction. It's called esterification, and their most common use is with scents and artificial flavors. You can also make something called polyester, which is a synthetic fiber that's used in clothing. Organic acids, vitamin C is a really common organic acid. They're weak acids, all these organic acids. Some interesting facts about them. Ethanoic acid is the main ingredient in vinegar. It's also known as acetic acid, and methanoic acid, formerly or informally called formic acid, that's found in stinging ants. So that is found in stinging ants. Amines, they're used in manufacture of plastics and also part of amino acids. And this is showing you an amino acid group. You have your amine and you have your acid group. Commonly asked about on the SAT subject test. They like you to know about amino acids. And amides, these are used in medicine. Penicillin is actually a type of amide that's used to inhibit the cell wall. One other interesting thing I want to talk to you about are compounds that have multiple functional groups. Here is cholesterol. It has this ketone group over here. It has an alcohol group over here. I'm sorry, it does not have that. It has the alcohol group over here. It has some of these cyclic compounds here. If we take cholesterol and body metabolizes it, it can be used for the making of testosterone. And then synthetically, we can take this and we can alter it and actually make it, if we alter this group right here from an H to an OH and a methyl group, we can take that and we can make it into an anabolic steroid. One last interesting thing I want to mention about with these types of compounds are caffeine. So caffeine, we mentioned this early on. Here is the amide group right here. Here's a ketone. Here's an amine. Here's another amine. So we have a whole bunch of groups for caffeine. And then here are other derivative compounds. This is actually narcotic drugs. This one on the left here is morphine. And if we alter these hydroxyl groups, the alcohol groups here, and make them into esters, it becomes a lot more potent. This is heroin. And if we then alter that group, if we go back to morphine and we change this to a methyl group here, and we change this to a methyl group here and a nitrogen, this becomes oxycodone. So as you can see, all these are derived from morphine, but depending on how we change up the compound will depend on how its strength changes. All right, so thank you for watching. I know this went a little bit long, and I appreciate you watching this video. Thanks so much.